In this video, we will be proving trigonometric identities. With trigonometric identities, we are going to be showing that one side of the equal sign will be equal to the other side. In doing so, we will only be simplifying one side of the equation until it is equal to the other side of the equation. So in the first problem, we are still doing what we have already been talking about, and that is reducing trigonometric identities. But now we know what we need to reduce it to, so sometimes these might seem to be a little bit simpler than what we were already working with. So notice that all of this we need to show is equal to cosecant. Now I'm going to draw a line here to show that we are not going to be working with this other side. So we will not be working anything at all with that side there. So here we're going to just go back and try to work with one side at a time. And notice with our trigonometric identities how we can go through and see, well, cosecant, we know that is 1 over sine theta times cosine squared theta, and we're going to put that over 1 since it is multiplying to a fraction, plus sine theta. So here with our multiplication, notice that's going to give us cosine squared theta over sine theta plus sine theta. From there, we're going to get a common denominator, which I'm going to put sine theta over 1. And this is going to be where we do our shortcut when adding fractions. We know it's plus because of the plus. We know the denominator is going to be the product of 1 and sine theta. And then we're going to say cosine squared times 1 is going to be cosine squared theta, plus sine theta times sine theta is sine squared theta. And by now, we've been seeing cosine squared plus sine squared quite a bit. That's a Pythagorean identity that is equal to 1. And we're going to have 1 over sine theta. And notice that 1 over sine theta is cosecant theta, which is what we have over on this other side. So we know we have proven that. All right, moving on to number 2. Same process. We just pick a side to work with, and a lot of times picking the most difficult side to work with would be the best. Here though, a lot of times both sides look pretty difficult, and so it's just a matter of picking a side. I'm going to pick the right side. If you want to pick the left side, that's perfectly okay, but I'm going to pick the right side. And with that, secant, I know that's 1 over cosine y minus, and then this is going to be cosine y, and I'm going to put that over 1. Now we're going to get a common denominator here and add those together, and notice we will have a minus sign. The product of the denominators is going to be cosine y, and then if I cross multiply, I'm going to get 1 minus cosine squared y. And again, that's going to be from one of our Pythagorean identities that we just talked about. It's just been rearranged, and we see that that is equal to sine squared y, and that's going to be over cosine y. And notice your sides match, so you are finished. Right? Again, same idea here. There's a lot of terms on the right side, so that's going to be the side I pick on this time. And so here, notice each term has a sine squared. So I'm going to factor out sine squared alpha. And we have cosecant squared alpha minus 1. And do keep in mind that 1 is there because we are dividing out sine. And then over here to the side, our Pythagorean identity that involves 1 and cosecant is going to be cotangent squared theta plus 1 is cosecant squared theta. So that's the trig identity that we need to be thinking about. We can subtract over our 1, and we do get what's here inside the parentheses. So I'm going to replace that with cotangent squared. So now I have sine squared alpha times cotangent squared alpha. And I would change that cotangent. Looks like that needs to be changed back to maybe in terms of sine and cosine. And cotangent is cosine squared alpha over sine squared alpha. And notice those sine squareds do cancel, and so we're left with cosine squared, and we are finished because that does match this other side. Okay, moving on to the next problem, number 4. The left side on this one looks more complicated, so that's the one we're going to work with. I see that if I go through and do my distributive property, I'm going to get at least one of the tangents to cancel, or I can combine what we have inside here to get a single fraction. I don't think it's going to matter which way we start, so I'm going to combine what's inside the parentheses first, just because that's what I feel like doing. There's no rhyme or reason. Inside here, remember, we're going to cross multiply those, so we get secant squared x minus tangent squared x over the product of the denominators, which is going to be tangent x secant x. And again, we have all of that equal to cosine, so it is over there. Now, let's look at an identity involving secant and tangent. We know that the trigonometric identity that we've been given is tangent squared theta plus 1 is secant squared theta. And so if we subtract tangent squared over, we have what's in the numerator here. So, and that's going to give us 1. So I'm going to rewrite this to be tangent x times 1 over tangent x times secant x. And then notice now those tangent x's will cancel. So I have 1 over secant x left. And even though we know the identity tells us that's cosine, we have to go ahead and write it anyway. And so that's going to leave us with cosine x. Okay, moving on. And again, more of the same. We are still reducing down these identities. There's more terms on the right side, so that's probably the side that I'm going to pick on. And notice that I do have a common factor here. So I'm going to factor out cosecant squared theta. And left over is going to be 1 minus sine squared theta. And 1 minus sine squared theta, I know that is cosine squared theta. That again is from the identities, and hopefully y'all have those on your note cards. Now cosecant, I know that's 1 over sine squared theta times cosine squared theta, and I'm going to put that cosine squared theta over 1. Multiply those two, and I have cosine squared theta over sine squared theta. And our quotient identity tells us that's going to be cotangent squared theta. So we have shown on this one that the sides are equal. All right, so for number 6, this is going to go all the way back to some of those first identities that we worked with. We were given tangent of negative u. That means that negative can come out since we're talking about tangent, and that's going to be negative tangent u times, and the same thing here, I'm going to move out that negative, so that's going to be negative sine of u. But remember, with cosine of negative u, that's the same thing as cosine of u. And we know that that all is supposed to be equal to secant u. Now, if I multiply these two terms together, I'm going to have a positive, because a negative times a negative is positive, plus cosine u. And tangent we know is sine u over cosine u. I don't know why I'm keeping the u's in parentheses. Just kind of felt like the right thing to do at the time. plus cosine u. You don't have to if you don't want to. It is kind of a lot of extra writing. If we multiply our first two terms together, we're going to get sine squared u over cosine u plus cosine u, and I'm going to put that cosine u over 1 because it looks like we're going to have to add those fractions. And so when we do, again, we're going to multiply sine squared u times 1, so that is sine squared u, plus cosine squared u all over cosine u. And let's see, sine squared plus cosine squared. I hope we're seeing that it's 1 now. So that is 1 over cosine u, and I know that is secant u. And so again, we have our sides to match. Okay, with number 7, it looks like we're going to need to start with the right side. And these two are looking an awful lot like identities. And again, a quick reminder, 1 plus, we started with the trig function first. So we know that cotangent squared x plus 1 is cosecant squared x. And so notice that this denominator, that entire part, can be replaced with cosecant squared. So let's do that. So here we're going to have 1 plus cosecant squared theta over cosecant squared theta. And now we're going to decompose this fraction, and that's where we divided this up. Since I have a single term in the denominator, I can rewrite this to be 1 over cosecant squared theta plus cosecant squared theta over cosecant squared theta. And now reducing this, 1 over cosecant, that's going to be sine squared with our reciprocal identities plus 1. And so since addition is commutative, we are finished. We have the same thing on both sides. Okay, for our next problem, goodness, it's going to be terrible no matter which way we go. So let's go ahead and just start on the right side, and it might be the best thing to do is flip everything to sine and cosine maybe. So let's see what we're going to get out of that. So for secant, I know that's 1 over cosine u plus cosecant's 1 over sine u. And then the denominator tangent we know is sine u over cosine u plus, and then the reciprocal, so cosine u over sine u. And it looks like since we have fractions both ways, let's go ahead and get a common denominator. And so this is where knowing this little trick really does help. So we're going to have sine u plus cosine u over the product of the denominators. So we're going to have cosine u times sine u. And then same process, so all of that is over sine squared u plus cosine squared u. And that's all over cosine u times sine u. And here we are dividing fractions. And so remember all of that, we've got to keep, change, flip. And we also have an identity here. All of this portion is 1. So I'm going to incorporate that here. So I'm going to have sine u plus cosine u over cosine u times sine u. And don't try to cancel anything here. You're adding in the numerator, so that's not going to work. Multiply by the reciprocal here, so that's going to be cosine u times sine u. Get my screen slid over. Times sine u all over 1. Because again, all of that identity is 1. And notice that since we are multiplying those two fractions, we can cross cancel. And when we do that, we're left with sine u plus cosine u. So we have verified these are equal. Okay, with this problem, you've got a couple of options. One way would be to FOIL out this side over here. So you would have your first, outer, inner, last. Or we could rationalize this other side. And believe it or not, rationalizing is going to be a little bit better for this. The FOILing will introduce 4 new terms that we'll have to deal with. So our rationalizing, that is just like what we have done in the past. You're going to multiply the top and bottom by, you're going to take the denominator and change this sign here in the middle. So we're going to multiply top and bottom by 1 plus cosine A and 1 plus cosine A. And so in the numerator, that's going to give us 1 plus cosine A all squared. So I'm going to have 1 plus cosine A times 1 plus cosine A. And we'll multiply that out here in just a moment. In the denominator, that's going to end up giving us, here we've got multiply, here we're going to have 1. And then our outer term is going to be plus cosine A. The inner term is minus cosine A. And then the last term here is going to be minus cosine A, cosine squared A, sorry. So the numerator, we can go ahead and put that together. That's 1 plus cosine A all squared over, and again, notice those terms will cancel. And I have 1 minus cosine squared A, which if we rearrange that, that's going to give us sine squared A. That's our identity. And notice both these terms are squared, so we're going to cheat a little bit here. And yes, this is algebraically sound. We're going to say that's 1 plus cosine A over sine A. And we're going to say, well, that's all squared. And that's perfectly okay to do that. Both of those have the same exponent in your dividing. You can do that. Now we can decompose this fraction. And so we're going to have 1 over sine A plus cosine A over sine A. And that is all squared. And then notice that's going to, again, simplify down to be cosecant A plus cotangent A, all squared. And now we have verified that other side. All right, so again, very similar, this next example. Instead of going through and rationalizing, though, this has already got 2 fractions added, so we're going to do our cross multiplying here. And when we do, we're going to have sine squared y plus, because that's the sign between them, and we're going to multiply those 2 together, so 1 minus cosine y times 1 minus cosine y. And that's going to be all over, and that's going to be the product of our denominators. So we're going to have 1 minus cosine y times sine y. Now please don't try to go through and cancel any of this. You cannot cancel any of it. You would just really go in a big circle and make a mess, so don't do that. We do need to FOIL out the numerator, so no little tricks here. We're going to have to multiply that out. So we're going to have sine squared y plus, here we're going to have 1 minus cosine y minus cosine y plus cosine squared y. And that again is all over this denominator. So we have 1 minus cosine y times sine y. Alright, so in the numerator, if you will notice that you've got an identity up there. You've got sine squared plus cosine squared. So I know that's all going to turn to 1. And so let's see, we've got 1 from there plus this 1. That's going to give us 2 minus, and we have 2 negative cosine y, so 2 cosine y. And again, that is all over 1 minus cosine y times sine y. All right, in the numerator, 2 is a GCF here. So I'm going to factor out 2, and that's going to leave us 1 minus cosine y, which is freaking awesome, because now that that's changed to a multiplication problem in the numerator, that 2 times 1 minus cosine y, that's going to allow me to cancel out 1 minus cosine y with 1 minus cosine y. So those are going to cancel, and I have left 2 over sine y, and that is going to be 2 times cosecant y. Now time for our homework problems. Alright, so again, this first part we are going to try to simplify down as much as we possibly can and show that one side is equal to the other. So here it looks like we're going to have to change some of that back over to sine and cosine. And I'm going to change cosecant. I know that's going to be 1 over sine squared theta times, and tangent squared is going to be sine squared theta over cosine squared theta. And then, of course, we still have our minus 1 there. Our sine squareds will cancel, and we're left with 1 over cosine squared theta minus 1, and that's going to give us secant squared theta minus 1, and that's going to be our trigonometric identity, and that is equal to tangent squared theta. All right, number 2. Number 2 kind of looks like we can decompose that fraction, but we really can't because there's 2 terms in the denominator instead of 1. So we're going to have to probably go change everything to sine and cosine and build this ridiculous looking fraction. So cotangent, that's going to be cosine x over sine x. And then all of that gobbledygook, we're going to change tangent is going to be sine x over cosine x plus cosine x over sine x. And again, in this denominator, we do need to get a common denominator and add those fractions. So the numerator, cosine x over sine x, I'm just going to bring that down. And all of that is over. And then in the denominator, we're going to cross multiply here. Again, we're going to get sine squared x plus cosine squared x. And all of that's over the product of the denominator, so cosine x times sine x. And again, right here, we see that identity sitting there. It's going to be 1. So I'm going to have here a big fraction. We're going to do that keep change flip. And so we have cosine x over sine x times, and I'm going to go ahead and do our reciprocal. So we have cosine x times sine x, and that's all over 1. And so we are going to cancel the signs. So it looks like we're left with cosine squared x. So again, here we have verified. All right, for our next problem, let's see what we can do with that one. Start with the most complicated looking side, which should be the right side, I guess. And so first thing that we can do is fix that cotangent of negative a. That negative is going to move to the outside and become positive on the inside there. So we're going to have tangent a times cosecant squared a minus cotangent a. Now let's go ahead, well, we don't need the parentheses there, but y'all get the idea. Now let's change everything to be sine and cosine, I would guess. So we're going to have sine a over cosine a, and that's going to be times let's see, cosecant is 1 over sine squared A, and then minus, and then cotangent is going to be cosine A over sine A. We can cancel one of those signs out, and so we're going to have 1 over sine A and times cosine A minus cosine A over sine A. All right, now let's go ahead and get a common denominator. We're going to do our crisscrossing here. So we're going to have sine of A minus, that's going to be sine A cosine squared A. And that's all over the product of the denominators. So that's going to be sine squared A cosine A. Okay, and so from here it looks like we can factor out a sine A. And so we're going to have sine A times 1 minus cosine squared A over sine squared A cosine A. One of those cosines, or one of the sines will cancel, sorry. And we also see that this portion right here is an identity. That is sine squared as well. So let's just write that in before we start doing a lot of canceling here, because I think if we take that sine A, that inside the parentheses is sine squared A, and all of that is over sine squared A cosine A. We're going to get those sine squareds to cancel. And so notice you are left with sine A over cosine A, which is tangent A. So we again have verified. Now looking at number 4, this one it looks like we might have to do some factoring. I know how we do not care too much for factoring, but we might have to here. Notice sine squared A, that's kind of the oddball in this problem because everything else is in terms of cosine. So let's see what we can do with that. We know that sine squared alpha plus cosine squared alpha is 1. And so if we wanted to replace sine squared alpha, that's going to give us 1 minus cosine squared alpha. And that right there, we can replace it. So coming back over here, I know 1 minus cosine squared alpha over 1 minus cosine alpha. Now, please, please, please don't try to start canceling. You can't. You're going to have to factor this first. You have to. So this is the difference of two squares here in the numerator. It's going to be 1 minus cosine alpha times 1 plus cosine alpha. And all of that's over 1 minus cosine alpha. And now that you have the top factored, now you can cancel quantity with quantity, and you're left with 1 plus cosine alpha. All right, so for number 5, we're going to go through, and it looks like we have a common factor of cosecant. So we're going to factor out cosecant squared beta. And that's going to be 1 minus secant squared beta. And over here to the side, our identity that we can work with, since we have that 1 and a secant squared, we have the identity tangent squared theta plus 1 is secant squared theta. And this one's going to take quite a bit of rearranging because I need 1 minus secant squared. So I'm going to subtract secant squared over. So I'm going to move tangent squared over. So everything inside the parentheses there is going to be a negative tangent beta. And looking at this other side, seeing that negative there, that's a good indication that that's probably the correct move there. Let's change everything back over to sine and cosine now. So we have 1 over sine squared beta times a negative sine beta over cosine beta or my goodness, that should be squared, y'all. Let's make that squared beta. Gracious. Now those are going to cancel. And so we have negative 1 over cosine squared beta. And that's going to be negative secant squared beta. So that works out. All right, on to the next problem. It looks like really we probably should work with the left side here and change those over to sine and cosine, and hopefully that'll help us. So tangent y, that's going to be sine of y over cosine y plus, and over here cotangent, that is cosine y over sine y. And we do need to get a common denominator, and so we're going to have sine squared y plus cosine squared y. And that is all over cosine y times sine of y. The numerator goes to 1. That's one of our identities. So we have 1 over cosine y times sine y. And that can be decomposed into 1 over cosine y times 1 over sine of y. And that's going to change to be secant y times cosecant y. Okay, so for number 7, it looks like we're probably going to have to start out with foiling this left side. And so when we do that, our first term we have tangent beta minus tangent beta times sine beta, the inner term plus secant beta, and then minus secant beta times sine beta. Alright, and probably need to change all of this mess into sine and cosine. So we're going to have sine beta over cosine beta minus, again, sine beta over cosine beta times sine beta. And I'm going to go ahead and put that over 1 plus 1 over cosine beta minus 1 over cosine beta times sine beta. And again, I'm putting that sine beta over 1. All right, and let's multiply together what we can. And so we have sine beta over cosine beta minus, and then we're going to say sine squared beta over cosine beta plus 1 over cosine beta, and then minus sine beta over cosine beta. And it looks like we have two terms that are going to cancel, so yay. And so let's see, here we have a common denominator, and so we have negative sine squared beta plus 1 over cosine beta, and that's the same thing as if we had 1 minus sine squared beta, which we know that's going to be cosine squared beta over cosine beta, and that's going to reduce to be just cosine beta. So that matches this other side here. Okay, for our next problem, it looks like we are going to change everything back over to sine and cosine on the left side, and hopefully that'll lead us into the right side. So cosecant, we know that's 1 over sine theta plus, and cotangent is cosine theta over sine theta. And here it looks like we're going to get 1 plus cosine theta over sine theta. And not much more we can do with that. So we could go ahead and do that ugly rationalizing that we did in one of the previous problems. And this one we're going to do reverse. We're going to multiply top and bottom by 1 minus cosine theta over 1 minus cosine theta. And let's see what that's going to give us. Here in the numerator, we're going to get 1 minus cosine theta. And then on the inside here, plus cosine theta. And then we're going to get minus cosine squared theta. And all of that's going to be over, and I would definitely not multiply out the denominators. Very rarely is that ever necessary. In the numerator, notice the cosines do cancel. And then we're given 1 minus cosine squared, which, again, that's an identity. That is sine squared. And then all of that is over sine squared theta times 1 minus cosine theta. Those sine squares, let's see, that bottom is only one sine. So it's going to cancel, leaving a sine. And so we have here sine theta over 1 minus cosine theta. And now we have our sides to match. Okay, so it looks like in number 9, we're going to have to change everything back over to sine and cosine. So for tangent alpha, we're going to make that sine alpha over cosine alpha plus cosine alpha over sine alpha. And every bit of that is over sine alpha times cosine alpha. And again, we're going to add that numerator. So we're going to have sine squared alpha plus cosine squared alpha over cosine alpha times sine alpha. And all of that, that's just the numerator, over sine alpha times cosine alpha. And so all of this in the numerator, keep in mind, that is an identity. That's all going to become 1. So I have 1 over cosine alpha times sine alpha. So there's the numerator times the reciprocal. Remember, it's keep, change, and flip. So that's 1 over cosine alpha sine alpha. And so we're going to end up with 1 over, and that's going to be cosine alpha times sine alpha all squared. And so, goodness, we can, it looks like we might have to work with the other side and reduce that down some. All right, so let's see if we can do that. I'm going to change colors. And I'm going to say, okay, that side's as far as I can go. So let's look at secant alpha plus cosecant alpha. So that's going to be 1 over cosine squared alpha plus 1 over sine squared alpha. Hey, here we go. That's going to work because, again, we're going to have to get that common denominator. So we're going to have sine squared alpha plus cosine squared alpha. And that's over cosine squared alpha times sine squared alpha, and that's going to work because then that numerator is 1 over cosine squared alpha, and that's going to be times sine squared alpha. So it does verify. You just had to work both sides, but again, you work them independently. You did not add or subtract anything across the equal sign, so it's perfectly okay. All right, last problem. And let's see, a couple of ways to do this one. I would go back, though, and do our rationalizing here. This has every indication that it wants us to do rationalizing, and it's because of just the general setup. And so I'm going to take that denominator, and that's what I'm going to multiply top and bottom by, but I'm going to put a plus sign. So I'm going to get cosecant x plus 1 over cosecant x plus 1. All right, and now I'm going to go ahead and multiply across top and bottom. And again, I don't know if I would full out anything just yet. Maybe the bottom, because it looks like stuff will cancel. But the numerator, we're just going to have cosecant x plus 1 all squared since we're multiplying by the same thing. And then in the bottom we're going to have cosecant squared x plus cosecant x minus cosecant x and then minus 1. So we're going to have those parts to cancel. And so again, I still have cosecant x plus 1 all squared, and that's going to be over, and this looks like an identity here. You have cosecant squared x minus 1. And if we check our identities, all of that bottom is going to change to be cotangent squared. So again, we have cosecant x plus 1 all squared over cotangent squared x. And this is where we can decompose this, so we don't have to do a whole lot of multiplying out. We can say this is the same thing as cosecant x plus 1 over cotangent x all squared. And we are almost finished, maybe. So here, that means that, I'm going to draw a line up here. This is to be continued, the longest problem in the world. You have cosecant x over cotangent x plus 1 over cotangent x. And all of that is squared. And so we're getting closer to getting that answer. On the inside here, cosecant over cotangent, that's going to be 1 over sine x over cotangent x is cosine x over sine x, and then plus 1 over cotangent, we know that is tangent x, and I'm looking at the other side saying I need to leave that one, tangent x. And so here, notice those signs. If we do our keep change flip, those signs are going to cancel. I'm left with 1 over cosine, and so that's going to give me secant x and then our tangent x. So this has finally been verified.